page 594, number 53 onwards, it just says solve. 5x plus x onto x minus 7 equals 0. Well, it doesn't look like we have a quadratic. We don't have a simple equation. Nothing's really factored. So what we do, go ahead and create a trinomial out of this. 5x plus x squared minus 7x. And then with that one step, we realize, oh, okay, we have a trinomial here. We just have to rearrange it. So we get x squared plus 5x. Do that again, x squared plus 5x minus 7x equals 0. X squared minus 2x equals 0. And now we factor this. Okay, now that it's simplified, and we get x with the GCF. X is factored out, and we get x minus 2 equals 0. Now we have something we can work with. Either x equals 0 or x minus 2 equals 0. X equals 0 or x equals 0 or x, we add 2 on both sides, and we get x equals 2. So our solutions are 0 and 2, and we're done. And sure, you could use the quadratic formula, but you wouldn't be able to use it unless you rearrange things like we did. This would be a equals, okay, if we have x squared minus 2x equals 0, we have a equals 1, b equals negative 2, and c equals 0 because there is no c. We have to like pretend it's there. We could put plus 0 equals 0. So that's what we plug into our quadratic formula. First of all, let's do our discriminant b squared minus 4ac, which is equal to b squared, that's negative 2 squared, minus 4 onto 1, and c, which is 0. So we get 4 minus 0, because negative 4 times 1 is negative 4, but times 0 it's equal to 0. And that equals positive 4, which is, that means that b squared minus 4ac is greater than 0. 2 roots. And that checks out with what we got. We have 2 roots. That means we're going to get a parabola, okay? We know it's a parabola because of this x squared. We're going to get a parabola going through 0, okay, and 2. These are the x-intercepts right here. And if that's 1, then that's 2. There's our 2. Those are our x-intercepts. And that means our graph is going to look something like, and I'm just sketching this, but we're going to get something like that. Okay? And this is the graph of y equals x squared minus 2x. All right? And our roots are 0 and 2. And that's exactly what they are. It's the point 0, 0, and the point 2, 0. Done. Okay, let's look at number 57. Y plus 4 onto y plus 3 equals 15. Now, that'd be all factored out. That'd be nice, except for the fact that it doesn't equal 0. So it won't work. We have to go ahead and use the FOIL method. Okay? And inside. First, y times y is y squared. Y times 3 is 3y. 4 times y, the inside, is plus 4y. And then 4 times 3 is equal to 12. And that all equals 15. We got to go ahead and solve this. So we get y squared plus 7y plus 12 equals 15. We're going to subtract 15 on both sides. We're making this equal to 0. We get y squared plus 7y minus 3 equals 0. And now we go ahead and factor that, but we actually don't need to factor it. I'm not even sure if it will factor. In fact, it won't. If you take the factors of 3 and 1, there's no way they'll combine to be 7. This is a good example of when we use the quadratic formula. Now, what's b squared minus 4ac? Let's see the nature of the roots. B squared minus 4ac, well, a equals 1, b equals 7, c equals negative 3. B squared minus 4ac is 7 squared minus 4 times 1 times negative 3. That's 49 plus 12, which equals 61. And when we use our quadratic formula, we get negative 7 plus or minus the square root of 61 all over 2 times 1, which means it's negative 7 plus or minus the square root of 61 all over 2. Now, that's going to give us some kind of decimal. We can write it negative 7 plus root 61 over 2 and negative 7 minus root 61 over 2. Those are our two roots, and if you want, you can go ahead with your calculator and get your decimals for those. But basically we're going to have two roots, and those are our two roots. If we were asked to graph this, we would need to put those in decimal form. But for the purposes of this question, and when they ask you to solve for the two roots, you can leave it like this. There's no problem. You don't have to do the root of 61 in your calculator. You can leave it as negative 7 plus root 61 over 2 and negative 7 minus root 61 over 2. All right, number 61. Use a graph to find the roots of each polynomial. Well, here's our polynomial. We need to use a graph. Well, how do you do that? You don't have anything equal to 0. You don't have f of x. You don't have y. What you do is you set this equal to f of x. F of x equals x squared plus 2x minus 8. And you need to create a graph out of that. You get x and f of x. You could use y if you wanted. And it's plug numbers in. F of x, if you do f of 0, this equals 0 squared plus 2 times 0 minus 8. Negative 8. So we put in 0, negative 8. If we put in, let's see here, f of 1, you get 1 squared plus 2 times 1 minus 8, and it's equal to negative 5. All this is from your graphing that you learned in Chapter 7, first semester. So that goes in there. That's 1, negative 5. I keep on putting in numbers. Try to stick around 0, although we don't know what we're going to get exactly. We'll try f of negative 1. We're going to get negative 1 squared, and we get 1 minus 2 minus 8, which is negative 1 minus 8, and that's negative 9. Okay, so if we graph this, we are going to have mostly negative numbers, but let's look at 0 and negative 8. 1, 2, 8 down here. We've got 1 and negative 5, negative 5, negative 1 and negative 9, negative 1, 9. Looks like we have a parabola that's kind of curving this way. Let's try a number over here. Let's try negative 3, for instance. F of negative 3 equals plus 2 times negative 3 minus 8, and that's 6 minus 8. That's equal to negative 5. And, oh, look at that. Now we have our pair, which means our parabola is going to loop back up. So negative 3, 1, 2, negative 3, and negative 5 is going to be right there. And now we have our shape. All right. I'm going to sketch this again. It looks, there we go. Notice that here's our x-intercept here, and here's our x-intercept there. So how do we find those roots? Well, now we know this is going to be something like, we don't know what it is exactly, but it looks like approximately 3 or 4, and over here, I don't know, negative 6 or 7. Now that's just an estimation, as graphs give us an estimation. To actually find out what those roots are, again, we go back, we use our quadratic formula, x squared plus 2x minus 8. We've got a equals 1, b equals 2, and c equals negative 8. Put them in, x equals, let's look at our b squared minus 4ac. We know we're going to have two roots because we already figured that out with the graph. Our discriminant, sure enough, is equal to 4 plus 32, which is equal to 36. And we're going to get our two roots out of this. This x equals negative 2 plus or minus square root of 36 all over 2. That means this is negative 2 plus or minus 6 all over 2. That means it's equals, okay, negative 2 plus 6 over 2, negative 2 minus 6 over 2. That's equal to 4 over 2, and negative 8 over 2. 2 and negative 4 are our roots, and that pretty much bears out on our graph here. So our roots are 2, 0, and negative 4, 0. And this is a sketch, of course. This is, 1, 2 here, 2, 0 is where it goes through, and negative 4, 0. The shape of the graph is parabola. The vertex is down here. These are the places where the parabola, the graph of this function, go through the x-intercept. These are our two roots, these are our two solutions, and we found this, and there's different ways to find it. You can graph it, estimate it, as we did, or you can go ahead and use the quadratic formula to find the roots, using the discriminant to tell you how many roots there are going to be. Immediately you'll know what kind of shape you're going to have.